Now we'll see how to find. Suppose we have a plane. This is a plane and point is here. What I want to find this is your P now. Okay, so whatever the plane may be, I want to find a perpendicular distance of a point from this plane. Okay, so this is perpendicular to the plane. This is what suppose this is M now. This is what PM is a perpendicular to the plane, and I want to find that distance PM now. Okay, so this is the theorem for to find a perpendicular distance of a point from the plane. Okay, the perpendicular distance of a point P x1 y1 from the plane. So this plane is in the normal form. So if plane is the normal form, then this is the plane. Okay, so we'll see direct the formula for if the plane is not normal form, then that also we'll discuss later on. Okay, so the equation of the plane through P x1 y1 z1 parallel to the given plane. So your plane is what? Lx plus my. What we did? This is your original plane. So what I did? I have taken the plane parallel to this one. Okay. So now the equation of this plane parallel is of the form. It is differ by constant only. Okay. So equation of this plane is nothing but Lx plus my plus nz is equal to P1. Now, so what is here? It is parallel to this one. So that means what here? This Lx1 plus my1 plus nz should be the P1, because this is the passing through x1 y1 z1. So that means that P x1 y1 z1 satisfy this equation. So Lx1 whatever this P1 is your this. Okay. So this is the equation of these two planes are parallel now. Okay. This is your original plane. This is your plane passing through the P point P. This is point P. Okay. So this plane is this plane and this plane is this. Okay. Okay. So your P is here. So this is L now. This is what? L P now. Okay. So P is what? That plane. Okay. So now draw OK prime perpendicular from the origin to the parallel planes. Okay. We take that K and K dash. Such way that OK is your small p and OK prime is your P1 now. Okay. So draw PL perpendicular to the given plane. Okay. Then PL is equal to mod of this PL is equal to K OK prime minus OKR. This whatever which one is the small. So distance is always positive. So we have taken this. OK prime is what? P1. But what is the value of P1? Lx1 m1 this. So we have put here and we get the required distance. Okay. So we get the required distance. So suppose your your equation of a plane is not in the normal form, then what to do? Okay, so we write a formula for that one. We write in the form of note now. Note. The perpendicular distance of Px1 y1 z1 from the plane ax plus by plus cz plus d is equal to 0. So you have to write the equation of plane in the equal to 0 form if you want to find a perpendicular of a point from the plane there. Okay, so I'll say this is Pm now. This is mod of, because distance is always positive, therefore I have taken the mod. So whatever this you have to write, instead of this x y z you have to write the point x1 y1 z1, x1 plus b y1 plus c z1 plus d upon root of x square coefficient of x y z, the sum of the squares of the coefficient of x y z. This is the perpendicular distance of a point P from the plane. This is the formula. Okay, so if you remember, this is the formula while solving the problem. We also write a note now. Note this is 1, 2. Okay, distance between the parallel planes ax plus by plus cz plus d is equal to 0, and if two planes are parallel, then they are differ by constant only. So coefficient of x, y, z are same now. Plus d prime is equal to 0. Each given by I will say this is Pm now. Pm is equal to mod of d minus d dash or d dash minus d upon root of a square plus b square plus c square. Okay. So d minus d dash or d dash minus d, whatever you can take, because we are taken in the mod. So this is the perpendicular. This is what perpendicular between the parallel planes. Okay, or distance between the parallel planes. Okay, so we'll solve problem on it. Find the distance of the point 2, 3, 4 from the plane 3x minus 6y plus 2z plus 11 is equal to 0. Okay. Solution. The distance, just erase the distance of the point I'll say this is P 2, 3, 4 from the plane. If your plane is not in equal to 0 form, you have to write that in equal to 0 form. Your plane is already written in the equal to 0 form. I'll say this is Pm. Doesn't matter what else. Okay. So what is here? 3. X is what? Your x coordinate. So you have to write all the things as it is. Only replace the x, y, z plus 11 upon the coefficient of x square, coefficient of x square plus coefficient of y square plus coefficient of z square. Okay. So this is equal to what? 6 minus 18 plus 8 plus 11 upon root of 9 plus 36 plus 4. So this is equal to what? So this is a 19. This is 1. So this is 7 upon 7. So this is 1. 7 upon 7. So this is 1. 1 is the perfect distance. Okay. Anything now, but the point is different, plane is different. If this is what is equal to 11, just write minus 11. Whatever this. I hope that you can solve any problem on this to find a perpendicular of a point from any plane now. Okay, just you have to replace here what in the numerator. Just you have to replace your x, y, z as a point, and under root of just you have to write the sum of the squares of the coefficients of x, y, z. Very simple formula to find a perpendicular distance of a point from the plane. Like find the distance. Find distance between the parallel planes twice x minus twice y plus z plus 3 is equal to 0, and 4x minus 4y plus 2z plus 5 is equal to 0. Okay, solution. Given that equations of parallel planes twice x minus twice y plus z is plus 3 is equal to 0. We call this as 1. Okay, so 4x minus twice y plus twice z plus 5 is equal to 0. We call this as 2. Okay, now here what? The coefficients of x, y, z must be same. Either you have to divide by 2 here. Okay, something is wrong. 4 is there. Okay, 4 is there. Okay, something wrong. So instead of dividing by 2, we get here 5 by 2. Okay, so what we do? We will multiply by equation 1. Okay, so 1 implies 4x plus minus 4y plus twice z plus 6 is equal to 0. So I call this as 3. So 1 and 3 are the same now here. I have to make, if the coefficients of x, y, z are not same, so either by multiplying to any one of the place by some number, okay, so that the coefficient will be same. So if the coefficients of x, y, z are not same, you will not get the same. So then the problem is wrong. So that means what here, the planes will not be parallel. Okay, d is equal to what here? I can say 5 and d dash I can take 6 now. Okay, so distance between parallel plane is equal to mod of d minus d dash upon, just I will write a formula, x square plus b square plus c square. So your d is 5 minus 6, whatever this you can take anything whatever this. So this is what, 4 square minus 4 square minus 2 square. So this is same as what, minus 1 upon root of 16 plus 16 plus 4. 16 plus 16 plus 4. Whatever the answer, you have to accept this. So minus 1, so this is 1 by 6 now. 32 plus 4 is 36, that is 6, so 1 by 6. So 1 by 6 is the required answer. I hope that you understand this one, how to make this coefficient of whatever this may be. You have to write d minus d dash or d dash minus 1. Okay, so you may write this d and d dash. Okay, if you don't want to write the d and d dash, don't write this, just write a formula and write whatever this constant. This is your d or this is your d dash. 6 minus 1, 5 or 5 minus 6 1. Just write this formula. Okay, don't write the value of this one, d is equal to 5, d dash is equal to 6. Just replace that. Okay, so you will get. So both the problems are very easy. Next, bisectors of angles between two planes. Okay, so just we'll take a theorem. The equations of the planes which bisects the angles between the planes ax plus by plus cz plus d is equal to 0. a1x plus b1y plus c1z plus d1 is equal to 0. R ax plus by plus cz plus d upon root of a square b square plus c square is equal to plus or minus a1x plus b1y plus c1z plus d1 upon root of a1 square plus b1 square plus c1 square. Okay, so this is just a theorem where we will not prove this. Okay, so to solve the problem we have to use this one. Okay, we'll take a problem. Find the equations of the planes bisecting the angles between the planes x plus twice y plus twice z minus 3 is equal to 0. 3x plus 4y plus 12z plus 1 is equal to 0, and specify and specify the one which bisect the acute angle. Bisect the acute angle. Okay, solution. Instead of solution, what we'll do, given that, okay, instead of this directly you can write this, okay, solution. The equation of the planes bisecting the angles between the planes, right, on the thing in the equal to 0 form. R between the planes. You have to write the equation of the plane. Okay. So first plane is what? X plus twice y plus twice z minus 3. You have to write upon coefficients of x, y upon the sum of the squares of the is equal to plus or minus. Okay. So you have to write the second plane in the equal to 0 form upon root of 3 square plus 4 square plus 12 square. Okay. So this is what? X plus twice y plus twice z minus 3 upon this is what? 8 plus 1 9. So this is 3 plus or minus 3x plus 4y plus 12z plus 1 upon so this is what? 144. This is 144. This is 16 and this is 9 and this is 9. So this is 169. So 169 is 13 is 13. So you have to multiply by 3 here. So 13 x plus twice y plus twice z minus 3. You can write plus or minus. Okay. So 3 into 3x plus 4y plus 12z plus 1 is equal to 0. Okay. So if you take the plus sign, you get a one plane, and if you take the minus sign, okay. So we'll take the plus sign now. So 13x plus 9, 13x plus 9, 13x plus 9. So that is what? 22x. Okay. So this is 22x. So this is what? 13 into 2. 13 into 2 is 26. 26 plus 12. 26 plus 12 is 38. Y. Okay. 26 plus 12. Okay. So that is 38y. Then this is what? 26z. 26z. And this is what? 36 now. 36. So this is what? 62 now. This is 62y. 62y. Then this is minus 39. Minus 39. Plus 3 now. Plus 3. So this is minus 33 is equal to 0. Or we'll take the minus sign. We'll take the minus sign. We'll take minus sign and see what is this. 13 minus 9. 13 minus 9. 13 minus 9 is 4x. 4x. Then this is what? 26. 26y. And this is what? Minus 3. So minus 12 now. Minus 12. So this is what then? 14 plus 14 y. Okay. Then this is what? Again 26 is here. This is minus then. Okay. So minus 36 now. Minus 3. So minus 10. Minus 10 z. Okay. So this is minus 39 now. This is minus 39 and minus 3 then. Okay. So this is what? Minus 42. Minus 42 is equal to 0. So these are the planes. These are the equations of the planes. Okay. So that will not specify the angles. because it is complicated for you, so we will not do that. Okay, so I hope that you understand this one. Okay, so now we'll stop here. Thank you.